I am here to teach the basis of differentiation. Like now, with the basis of differentiation, you can see the chain rule. All about the chain rule. The chain rule has so many rules that has to be followed, like to find the y of x. So I can get. So these are the measure. For the measure basic rule. When y is x of n, to look for the dy of dx will be to put the into a will be you look. First of all, you have to let y be equal to f of x. For here, you do f of x square. You do n times negative 1. 1 should be always up there. For the second rule, y is equals to ax. For dy of dx of it, dy on dx, it has to be negative. It has to be the inverse. It has to be the inverse of x, e of f of x. But now, since it is like that, so here we put 1. So you will put 1 ex. The reason why the x is left there is just because it's still a value of f of x. That's why it's left there. For the third solution, you can find, for the third one, y of in x dy on dx will be equals to 1/3. As you can see, in ln itself is as considered on its own to be the inverse of any function that it carries. Now, like if you want to get y equals to in f of x, instead dy on dx will be equals instead to f of inverse of x on f of x. What I mean is that, example, let's just only say y is equals to in cos of x. Now as you can see, dy on dx will be equals to dy on dx now will be equals to this. Now like that, you don't consider the in. Now like that, the in is a bit useless. You cannot consider the in. Now you take the inverse of this. The inverse of cos is negative sine x. Then now you take it all over the original value, which is cos, to give this answer. So let's see on this rule. The chains rule. The chains rule is a combination of all of this. Now, a simple example of it. With the chains rule, you can have y equals to f of u. U will be now equals to f of x. But now y now is equals to this in cos third x. Now if this type of equation now is given, as you can see now like that, it shows that, it proves to you that, look at another method of which you can solve it. You can do y on in of cos of x. You put the 3 of x, 1/3. Now you let u be equals to in of cos of x on 3. Now now y will be equals, now since you have equal y to that, so u to that, so u will be equals to that. Now like that. Now dy on du will be equals to 1/3 of u. Now as I said earlier, now you take 1/3 minus 1, which now will give minus 2/3. So minus 2/3. So you can see 1/3 in of cos of 3. Now you express back the u, since you are finding a bit what you are looking for, over 2/3. Now you let cos x be equals to v. You are letting it like that, so I can be able now to find x, to find d, in order to find the x on du. So if u be equals to in over v cube, means that u on v, you have to first find du on v in order to get the real value. So the inverse of that plus this, which will give you, which all of this now like that will give you equals to 3 cos x. Since v is equals to cos x, now d of v on d of x is equals to negative sine x. So dy on dx will be equals to dy on du times du on dv times dv on du. We are using this method like that in order to eliminate v. Because now that v is not in our vocab, it's not now to be used. So we'll have 1/3 of in cos 3x negative 2/3 times 3 on cos x negative sine x. Now you see like that. Now you put it like this, tan, because of this sine, all over this will give minus over in cos x. So this will give 2/3, which will be equals to negative tan x all over in of cos 3x on negative 2/3. Negative have caused this in cos x to go down. So this be the answer. Thank you.